This tutorial will help you design the axle bolt for the toy train. We're creating a standard part, and we start by choosing a 2D sketch, selecting a sketch plane. And once again, with this bolt, just like we've done with a couple of the other parts, we're going to do a profile of a cross section. So we have the vertical center point. Then we have half of the base as a radius. And we come back up, making sure everything's perpendicular. And then we have another little piece underneath the cap. And in this bolt, we actually have a small vertical piece. And then we have an arc. So if we look at it, let's see if I can zoom in. The small vertical piece is this flat piece here. And it will be a thickness of 0.031. We need to talk about the one thing that seems to be missing from this diagram, and that is the overall height or the overall length of the bolt. It's hidden here. This is a 1-inch bolt. Now, 1 inch is referring to the shaft. It is not including the cap. So when we say a 1/4 inch 20 UNC, 1 inch with a 1/4 inch offset. So 1 inch is the length of the bolt part. The 1/4 inch offset is this piece here, right underneath the cap. So 0.25 would not have any threads. So that's what this is indicating is the threading. 20 UNC is the type of thread. 1 inch is the length of the shaft or the threads, and then 1/4 inch offset is how it should be smooth. So the threaded part's what goes into the wood. The smooth part is what the wheel will rotate around. And so then we have this total 0.125 total thickness for the cap itself. So our overall length of the bolt is 1.125. So let's go back and add those. .125 and just 1. And then this little one here was 0.031. Okay, now we need to work on our horizontal measurements. So diameter, the diameter of the width of the cap, the diameter of the cap is 0.422. So that means the radius of the cap is half of that, 0.211. So when we talk about the radius of the cap, we're talking about from here to here, 0.211. And then the diameter of the bottom, it's a 1/4 inch bolt. We'll double check. The diameter of the bottom is 1/4 inch. So that means the radius is half of that. So if we have 1/4 inch, which is 0.25 divided by 2. So 0.125 should be our total diameter. So it looks like we're done with the basic measurements. Now we need to get to the arc, and notice the top of it's flat. So that's going to change what we do just a little bit. So if the top of it's flat, and let's see what that circle is. That diameter is 0.25. So that does change what we do here. I need to go back and add another line to give me the flat part right here. And that line, if the diameter of this flat, which will eventually be a circle, if the diameter is 0.25, then this needs to be 0.125. So really our arc is just connecting from here to here. Oh, I chose circle instead of arc. Undo that, click arc. And bow it out just slightly. And we'll go back and put that measurement in after well, no, we can do it now, I believe. Let's see. Yeah, it should be a 0.236. 0.236. So dimension here, 0.236. And that is the profile of the bolt. Now we revolve the bolt. Should already select our profile. Click revolve. What axis do we want to revolve around? Well, we're trying to get this to swing all the way around, so we're revolving around this axis. Click OK. So that is the starting blank for our bolt. So once you have a blank, then it has to go into another machine that's going to put threads on it. And it'll have to go into another machine to drill the hole in the top. And in this case, it's a hex. This bolt is meant for an Allen wrench. And so we have a hex socket in the top. That's not very difficult. We can do that one first, then we'll put the threads. Let's go ahead and do the chamfer at the bottom just so we don't forget. A 45.03 chamfer. A little bit different than the ones we've done before. So angle it to where you can see the bottom by clicking on your rotation cube. Click on chamfer. Change it to the middle button where you have a distance and a face. The distance was 0.03. So the face is the bottom. The edge is here. Click OK. So that's the chamfer on the bottom. Very good. All right, now let's see if we can go ahead and apply threading. So if we look at our tools, do we see threads? There it is. There's threads. Let's apply thread. Now this isn't actually going to carve the bolt with threads, but it is going to put a picture on there to show where the threads are. So let's see what we need to look at. So where it says depth, offset, so change depth to 1 inch and then change offset to 0.25. And that's what we want because we want it blank at the top. You could flip this around. Make sure it's 1/4 inch, 20 UNC. That's a pretty standard size. And then we click OK. And so there's the threads for the bolt. So the last thing we need to do is make the hexagon cutout in the top. So it's not really difficult, but we do have to add an extra step in the new version of Inventor. It's not going to let us pick up the center point of this. So let's put a new sketch on this top surface. Project the geometry of the circle. That's definitely what we want to do because we need that center point. Now I'm going to go to where it says rectangle, but I'm going to open that menu up and I'm going to go down to polygon. And it is a 6-sided polygon. That's a hexagon. So we click on the center. When we move outward, it makes the hexagon for us. I'm going to stop about right here. I didn't quite make sure it was level. Let me redo that. Because right now I can see this bottom line's a little bit crooked and that line's a little bit crooked. Well, actually, no. Let's just do a horizontal constraint. There. And that fixes it. So we did a horizontal constraint to make this perfectly horizontal so that it wouldn't skew any of the lines. Now, we needed to know a dimension for this. So the only dimension they give us Well, they said it's 5/32 across the flats, 0.111 deep. So we need 5/32 across the flats. And across the flats means from one flat side to the other. 5/32. So we're going to dimension from this flat to this flat. And we're going to type in 5 divided by 32. And now we're going to extrude this shape, but we're going to make it an extrusion cut, and the depth or distance in this case is 0.111. And now we have made the hexagon Allen wrench socket. And that is the bolt. That's it. Now, if you want to, let's find a color for it. I didn't do this with some of the parts. I can go back later. I think I'm going to do this one in, I like the blue chrome look. The polished blue chrome. There we go. And I'm going to click Save. Train, axle, bolt. And I know in one of the parts it says peg, axle, peg. It's really a bolt, so let's just call it an axle bolt. And that's it for that part. The next thing we'll do is a drawing sheet.